In the previous video, we showed how to extract information and graphs from the ThermoTXT. How about the ThermoALL TXT? Now, the ThermoALL TXT, as we already saw in the previous video, has a similar structure to the ThermoTXT. The only difference is that there is one entry for each snapshot that we save during the deformation of the structure, not just at the end of the optimization steps. So if we want to extract some graphs from here, you can still do the same as you did with the ThermoTXT. You open the file as text, you select everything with Ctrl A, you copy with Ctrl C, or you right click and you say copy. Then you go to Excel. Here we could open a new sheet. The other one was the thermal. This is the ThermoALL. Copy in position A1, find this small icon here and say use text import wizard, finish. So what can we do with these? What I recommend you to do is first to create a column called displacement. Here we are working under imposed displacement. So the imposed displacement in millimeters is nothing but the current displacement, the current particle position y minus the initial particle position y, which is this one. But the initial particle position, we want the same to be for all the columns, so the initial one we should put a $sign in front of the number 2. This, as you drag it down, means that it is the current value of y minus the initial value of y. So it is the displacement of particle 888. You see that this correctly goes from 0 to minus 0.4, and then it starts again. So this is where the second optimization step is starting. So you can take this formula and drag it to the end of this long file. So whenever it goes back to 0, one optimization step is over. During this optimization step, you see that the displacement is progressively increasing. Then probably the most interesting thing to plot in this graph is the total force. So we can draw force displacement curves for the structure as it progressively gets optimized. So the force total in kilonewton is the same as we did before, is the sum of all the forces that we are wisely recording in our thermal. And again, we can double click to get it to the end. And now we can start to plot graphs. For example, for the first optimization step, as the displacement goes from 0 to 0.4, the total force is increasing in this way. We insert a bubble graph, points and lines, and this is this more or less linear behavior that we are obtaining as we expect because we are using linear interactions. And then we can do the same thing for the second step. How do we do that? Well, we do select data, we add a new series, and we select the x from 0 to minus 0.4 displacement and the corresponding total force. Enter, OK, and you see that the system is becoming indeed stiffer. The second line is stiffer than the previous one. There is more energy accumulated underneath it. And then we could do the same for the third step. Again, select data, add a new series, and the third step is starting here, going down to there. Notice that there are multiple 0.4. We will see in a second what this is why, but you should select all of them. And again, you pick the total force, enter, and this is what is happening here. Let me increase a little bit the size of this. So what is happening here is that again the system became stiffer. It's a higher, the curve is above the previous two, but now when it reaches the minus 0.4 displacement, it does relax a little bit extra there. And if you see previous videos, I told you that when you use a rate that is too high in applying the displacement, you typically see some relaxation at the very end where the curve goes up, sometimes non-linearly, and then it goes down back a little bit. Well, in this case, this relaxation is very, very small. So you can still consider that the strain rate that you used in the input file was quite okay. But if you had a very profound relaxation here, then maybe you want to repeat the simulation, restart the DETO simulation with a lower rate. for imposing the displacement. But this is essentially how you can plot stress-strain curves at different stages during the optimization. So we could see as a last example here, the very last entry that we have created. So we add another series. For x values, we take the displacement, the last ones we have here, and the y values are the corresponding forces. And you can see how this last curve is very much higher than the previous. So the gray curve we had before, now this is massively bigger. We went up to 20 kilonewtons of force to generate the deformation. So with all what I've shown you so far, you are able to run a sample simulation and you are able to plot deformed configurations and trajectories from the dump files, create nice videos and pictures from them with color-coded chi and color-coded stresses, and you are also able to plot the evolution of the strain energy during the optimization process to see when you get convergence, and the evolution of the force displacement curve during the various stages during the simulation using the ThermoALL.txt file content.